Okay, let's take a look at programming. This will be a short video just talking about the basics of programming. There is so much that they could get into, but they are trying to keep it basic, trying to give you a little bit of information that you can practice on and do. Test out's part of that, and of course, Comp TIA and what they want you to know. You need to understand, obviously, that programming is doing everything, right? You build the hardware, and then you have to program the operating system. You have to program the firmware. You have to program the apps. Everything's programming, which is why programming is always in high demand. Programming, usually, people that gravitate towards it are usually creative but structured. What I mean by that is I'm a very creative person, and I rely on computers to structure things for me. If you come into my office, you will see that I have organized stacks of information. I don't do the whole filing system thing. Usually, if I use a filing system, it means I'm putting it away for a long time, just in case I need it, it's there. But otherwise, it's there in front of me. That way I can see it. And that's as far as my organizations go. And so as programming wise, I don't gravitate to that because I don't like the structure. If you go into Lydia Monta's office, nice and clean, right? She's a very creative person, and she also has a logical flow to how things are going to happen. And that's why she's much better at programming than I could ever be. And so really, when you take a look at this, what is programming doing for us? And where can programming be found? And of course, programming is doing most everything for us, and it can be found everywhere. And that's why there's not just one simple programming language to use. For instance, they mentioned JavaScript, which is kind of programming. It's more of a scripting language, which I have less trouble with. But it's not Java. JavaScript is not Java. HTML is kind of programming, but at the same time not. CSS, also kind of programming, and all that's used for web pages, to figure out web pages. And so they actually give you the opportunity to do some JavaScript, to deal with some HTML, to deal with some CSS, because they can actually have you do that much easier than to say, hey, let's do some Objective-C. Right? That's other classes. Lydia Mata offers C, C#, and Objective-C, those three classes. So if you really like this section, then you really want to get into, make sure you take as many of those classes as possible. A high demand for programmers. So let's take a look at some terminology. You got a programming language. And these are examples. As I said, C++ is the old, it's what C# kind of replaced, kind of. Python is very popular, Java and JavaScript. And then you deal with different data types. In other words, the data we're working with, that's what we're manipulating. What are they? What is it? Is it an integer? Integers are used for whole numbers. Float is used for numbers that have decimal places. Char, that can store a single text character that uses 1 byte of storage. So character, short for character, char. String is used to store more than one character, such as a word or a sentence. And so you have these different data types that you're dealing with, and you manipulate them through programming. And then you have your identifiers. So in programming, identifiers are used to define names of specific values. The two most common are variables and constants. A variable holds a value, such as a number of words or phrases. Variables can change the value they're holding. They're variable. Take an online banking, for example. Let me give you an example of that. And then, where are we? A programmer might want to keep track of a value that will never change no matter what, and that's a constant. So this is a value I'm going to use in my programming, and I don't want that one to change. And so you set it up as a constant so it won't. And then you deal with containers. Containers are types of identifiers that hold onto a set of values. And those are arrays and vectors. I always know when students start dealing with arrays in Lydia Mata's class, they always get more stressed when that happens. And so they give you an example of how that occurs. And then functions. In other words, one of the principal software developers to keep your code, DRI, DRY, sorry, don't repeat yourself. This principle helps you keep the code neat and organized. One way to keep your code dry is to use functions. Functions are snippets of code that you can write once and then reuse them wherever you need to, which is fantastic. I did not exist in the programming world when this was really a big thing, but you could take that function and say, well, I'm going to use this over and over again, and then that way you don't have to keep writing it over and over again. So in the early days of programming, most programmers were just simple lists of instructions for the computer to follow. And then object-oriented programming is much newer. And that's really looking at, I want to build this functionality, and then you're building this into smaller groups and tasks. It also is easier for you because you can take basically a function and dump it in there in the object-oriented programming, and then it says change the variable, and you just change those variables, the names of things, and it makes it easier for us to get the job done. We like to do that. Encapsulation is a huge concept, goes beyond programming, but encapsulation in object-oriented programming, it describes how data and methods are bundled together within one unit or a class of things that you're doing. So in other words, you're encapsulating it into this. We use that term in networking technology as well. Now, those are just the fundamental terms that you're going to be dealing with in programming, and you will have the opportunities to take a look at arrays and functions, and then to do quite a few labs on writing that. So be prepared for that as you go into Unit 8 for programming, a lot of labs to deal with, which is really, really helpful to give you a real solid idea of, do I like this, or did I just really struggle through this? This is also a good time to mention, if you get into something that really is like, what the heck is going on? Let's just pick that one out and start the lab. If you get into something, you're like, what? I don't know what's happening here. Remember that you can score the lab, and right here, it'll give you the explanations. In other words, it'll give you the steps. And that is important. I know that a lot of students see that as cheating. And to me, it's only cheating if you just go straight to that and you're like, I don't want to bother. Let me just look it up and go boom, boom, and I'll just put it in. When you do that kind of thing, right, you aren't learning anything. You're just, you seriously are just saying, you know what, I don't care about this topic. And even though it's going to bite me in the butt when I take other programming classes, I'm just going to look at what the explanation is and then go back and do it. I don't even know what happened. That's when it's cheating. You're not cheating when you go through and try it and you're like, I just don't understand this concept. And then you look at the explanation of what to do, because that helps you. That helps you. That is no different, really, than me standing there and saying, well, put it here and put it there and let's see what happens. Okay, what happened? Right. And so you can do that after, you do it a couple of times. I'll have students that'll say, I did that like 4 times. I can't get through it. Don't. Do it a couple of times and then look at the steps. By the time that you've tried to do it a couple of times, you will note that your brain will pick up on what they're telling you. That you'll go, oh, okay, so I'm missing this step. I need to do this. It is learning. So make sure that you take advantage of that and do it.